Module 1. Instant Access Point Introduction. In this first module, we will look at the standalone site issues, Instant AP's descriptions and features. We will look at an IP cluster and the virtual controller. We will look at the virtual controller election process, the country code selections. We'll have a small introduction into the GUI interface. We'll look at the local initial setup, and we'll also look at dynamic installation. Small or distributed organizations that require Wi-Fi access are often faced with many challenges. They require simplicity since they often lack IT resources or RF knowledge. They have requirements like multiple SSIDs, guest access, firewalls, intrusion detection, and radio management. These are all functions of a high-end enterprise class network. Unfortunately, small organizations are constrained by cost or have compliance mandates. Therefore, the organizations are forced to choose between cheap consumer-grade Wi-Fi gear, feature-rich but costly high-end wireless LANs, or simply do without wireless altogether. Aruba Instant APs were created to solve these issues. In this module, we will review how Aruba's IAPs can help resolve the Wi-Fi issues small and distributed organizations experience. Aruba-based controllers with APs or Instant APs. Aruba Instant is ideal for enterprise organizations with distributed locations, such as retail chains, K-12 school districts, or small independent offices. Aruba Instant gives the customer enterprise-grade access points with full features such as authentication, policy firewall, rogue containment, and adaptive radio management. It also provides basic wizard configuration with a simple plug-and-play philosophy. In the future, if a customer wishes to implement a full-featured controller-based network, then the IPs can very easily convert into regular controller-based APs and convert it back to an IP if needed. This way, no initial investment is lost, and this allows the customer to grow the network. Aruba Instant gives you enterprise-grade access points with a virtual controller design. All IPs in the same subnet will become a cluster and automatically join the virtual controller. For configuration, the customer will also get a basic wizard configuration with a simple plug-and-play philosophy. If the IP running the VC fails, then another IP in the cluster will take over the VC functionality. The IP is a full-featured enterprise-grade access point and doesn't use licenses. Some of the enterprise features that the IP has for deployment include multiple SSIDs that can be set up with 802.1x authentication or MAC authentication with the supported WEP, TKIP, and AES encryption. Captive portal authentication can be used for guest access. Users can be authenticated on an internal database or use external servers, typically a radius server. The VC serves as a proxy radius, therefore only one client is defined in the radius server to serve the entire cluster. Aruba Signature Adaptive Radio Management ARM technology is also implemented on the IEPs. This automatically manages the wireless LAN 2.4 and 5 GHz radio bands to optimize Wi-Fi client performance and mitigate RF interference. It also ensures that each Aruba Instant AP uses the optimal channel and transmit power for its RF environment. The IP has many features that a client can use to improve their Wi-Fi experience, including Client Match, which continuously monitors a client's RF neighborhood to provide an enhanced Wi-Fi experience, and if needed, an AP or band reassignment. For troubleshooting, APs can be used as spectrum monitors. There are also special features like voice-aware scanning. The IAPs also support a stateful role-based firewall. Roles have extended action, such as logging or blacklisting. There are predefined voice policies for various types of voice protocols. AppRF is Aruba Layer 7 firewall capability. The IAP also offers content filtering with a subscription to OpenDNS. Aruba Instant also has the OS fingerprinting feature that gathers information about each client connected to the wireless LAN. For management, an Airwave server can be used, or an Aruba Central, which is a cloud-based management system. The cloud-based Activate service will direct the IP cluster to the desired management system automatically. Since the security of the network remains of paramount necessity, the Aruba instance supports intrusion detection and protection with rogue detection. The 300, 200, 100, and outdoor series of APs can be purchased as controller-based APs or as IAPs. The IAPs can be converted to controller-based APs. They can also be reconverted as IAPs with a hard reset. Controller-based APs cannot be converted to IAPs. Remote APs are all shipped as instant APs and can be converted to wraps. This can easily be done using the cloud-based Activate service. IAPs in the same subnet will form a cluster. In each cluster, a virtual controller is elected. Normally, the first IAP in the subnet will become the virtual controller. If the IAP running the virtual controller should fail, then another IAP will elect itself as the virtual controller. The cluster supports an unlimited number of IAPs. However, it is recommended that networks with more than 128 APs should be designed as multiple smaller virtual controller networks with Layer 3 mobility enabled between them. There is a limit of 2,000 devices, but this is not a hard limit. All configuration is done on the virtual controllers and pushed down to all the IPs in the cluster. All the IPs in the cluster, including the IP in the VC, will advertise the same SSIDs. Zones can be created within a cluster to specify specific SSIDs on specific IPs. The IP93 will lock your cluster to a limit of 16 APs and a limit of 256 users. IPs can be in one of four states: initial, local, potential master, and master. An IP will start in the initial state. It listens for a master beacon. The master sends a master beacon every second. If no beacons are received, the IP times out and moves to the potential master state. The IP will now send out potential beacons, or it may receive a potential beacon from another IP. Then the rules of the election process will be applied to determine who should be the master. If the IP wins the election process, it becomes the master. If there is the possibility of two masters, then the election process will determine which should be the cluster master. If an IP was configured as preferred master, then that IP will boot up as the VC. The election process starts with any IP that has an IP address and not the 169 address. If an IP has a 3G or 4G backup link, then it is given more priority. The IP with a higher platform is given priority. When all of the platforms are the same, then the next parameter is the IP with the highest uptime. If all the IPs were booted at the same time, then the IP with the bigger MAC address is given priority. If two configured IPs are set to be the preferred master, then they will cause two IPs to run as VCs and will split the network. This is not recommended. IP deployments. If an IP has access to the internet, then the IP will start communication with the cloud-based Activate service. If the IP has been configured in the Activate system, Then the IP will be directed to a management platform or a controller. The following are 4 different ways in which your IP can be directed from the Activate system. IP to Airwave. The Activate service will give the IP address of the Airwave server, and the organizational information. The IP will then start the process of communicating with the Airwave server. IP to CAP allows you to reconfigure your IPs as campus APs and direct this AP to the IP address of a controller. IP to Central will direct the IP to start communications with the central cloud-based management system. IP to RAP is mostly used by RAP 3s, RAP 109, RAP 155 to convert them from IPs to RAPs. The Activate process will also tell the RAP the controller's IP address and the AP group this RAP belongs to. Someone installing this RAP at home would only need to connect the RAP to a modem at home with internet access, and the RAP would automatically come up with the proper SSIDs, authentication, and encryption. You have 2 choices for central management: Airwave or Aruba Central. Aruba Activate is a cloud-based service that helps you deploy Aruba devices and maintain inventory. When your company orders a new access point, that device is automatically added to your inventory in Activate. Once the device is in inventory, it can automatically or manually be associated to a folder with provisioning rules. The rules will direct your IP to an Airwave server or to Aruba Central for management and configuration. You can also convert your IPs to CAPs and direct it to a controller. RAPs start as IPs but can easily be converted to a RAP and directed to a controller. Activate will direct your IPs but will not configure the IPs. The IPs will receive its configuration from the Airwave server or central cloud. In the case where an IP is converted to a RAP or a CAP, the configuration will be pushed by the controller. For local deployments, the IPs will broadcast an open SSID. A client simply connects to the instant SSID of any IP in the cluster. The client will be redirected to the master AP website. Once connected, the client can log in using the default credentials admin. A pop-up window will appear offering a free 90-day trial to the Aruba Central Cloud-based management system. Aruba Instant Access Points are shipped in 4 variants: IPs destined for the US, IPs destined for Japan, IPs for Israel, and IPs for the rest of the world. Any IP shipped to US, Japanese, or Israeli address is preset to their country codes and cannot be changed. This is done to comply with the country's laws. The rest of the world IPs are not preset and therefore must be configured. After you successfully log in to the instant user interface, a country box appears. You will need to select your country code to proceed. Note, the country code box will not appear for the US, Japanese, or Israeli IPs. Once logged in, you will find yourself in the main monitor page. On the top display, you can see the network, access points, and clients. The instant AP information displays the name, country code, and virtual controller IP address. At the bottom left, you can select the language of the GUI display. The name of the IP network, along with the virtual controller static address, should be set. The name and IP address of the virtual controller will always be static information no matter which IP becomes the virtual controller. On the main GUI page, you can select the IP and then select the option to edit. You should give each IP a relevant name. You can also select which IP will be the preferred master. Whichever IP is enabled as the preferred master will also become the IPv4. You will need to reboot in order for these changes to take effect. If you cannot use DHCP, Then you may assign the IP a static IP address. The radio tab allows you to change the IP into an air monitor or spectrum analyzer. The uplink tab allows you to select the uplink management VLAN. In this module, we saw the standalone site issues where an IP can be helpful. We described the IP features. We looked at the IP clusters and virtual controller, and we looked at the virtual controller election process. We talked about country codes. We looked into the very beginning of the GUI interface. We looked how we can do a local initial setup, and we also looked how we can do dynamic installations.